we're going to look at the concept of a function. So to start with, we're going to define a function as a relationship between two sets. And the way this will work, this relationship is such that we associate a particular element of a set which we call the domain set with exactly one element of another set. And that other set we call the range set. So one good example of a function is if I took as one set members of my class, so members of my Math 120 class, and that's going to be my domain set. The range set will be days of the year, and so that would be my range set. My function is I would associate with each member of the class the day of the year you were born. So my function f is your date of your birth. So it's really the day of the year, not the year. That is my function, and I call my function f. Now it turns out that there are several ways that we can think of that. We have 4 or 5 ways, and some are visual. So this is one where we put up two sets and we show the association between them. A second is where we actually have a diagram where I say, here's my domain, and then I have a range set which will have different elements. And for each x value in the domain, it's going to be associated with just one y value in the range, and that's the function. So one of the things in this description is I can only have one arrow starting from x. I can't have two different ones. Each x can only have one arrow that starts from it. But I could call this x1, and I could have another point x2, and it's perfectly fine for x2 to go to the same y value. It's just that from x you can only have one arrow leaving, but you could have two different arrows going to the same point. Okay, and that's what it means to be a function. So the main thing here is from each element of the domain, each member of the domain set, only one arrow emanates. So from each element of the domain, only one arrow leaves it. Another way, a third way to think about a function is to think of it as a table. And we have the input and the output. So we have what we call the input, and then what it's associated with is an output. Very often input has the letter x. You put in a certain value for x, and out comes a certain value for y. And so we have tables that associate x and y. And these are ones that are very algebraic, because an example of a function would be I could say y equals x squared. That's a function because it's telling me that for any value x, if I square it, that's how I'm associating the y values. So if I put 0 in, there's only one answer I get out, 0 squared, which is 0. If I put in 1, there's only one answer from that, 1 squared. I don't get 2. If I put in -1, -1, I square it. I get the same y value, that's okay, but from -1, there's only one answer that comes out. But we also can have equations that don't represent functions. So for example, if I say x is y squared, x is always our input, y is our output. If I set up a table here with x and y, if I put in 1 for y, I get x is 1 squared, which is 1. But if I put in -1 for y, I get -1 when you square it is -1 times -1 is +1. This is not a function because the same value for x gave me two different y values. So it's as if I had one x having two arrows coming from it. So this would not be a function. So this is not a function. Now the next way that we have of thinking of functions, this particular table sort of indicates, because we have x and y, and we use that for graphing. So whenever we had x and y like that, where you plugged in numbers, we could get graphs on the Cartesian coordinate system. So for this one, we'll go to the next page and we'll look at what that means in terms of graphs. So our fourth one is to think about functions using graphs. So we're going to think about the xy coordinate system, and that comes from having a table of x and y values. So to start with, we'll just put up something that we know is a function, like for example, y equals x. That's the line that looks something like this. If we wanted to see that's a function, we could take any x value and we'd go up here to the line, and we see that x value gives us one particular y value. It's not going to hit more than one y value. So no matter where I put x, there's only one y value that's associated with that, because there's only one point on the line for that x. Let's look, though, at an example that isn't going to give us a function. So I'll put my xy coordinate system. Now I want to look at an equation like this. X squared plus y squared equals 4. So I have x's and y in here, which means I could come up with xy values that satisfy this equation in this table. And some people may have seen before that this is the equation of a circle. So this particular circle is the circle which has the radius equals 2. And this one does not describe a function. You guys, this is not a function because I choose an x, and there's that same x, and we notice there's more than one y. In fact, for that x, there are two y's. Anytime there's one x value that gives you two different y values, it's not a function. So this is not a function, and it gives rise to, with graphs, the way you decide if something's a function. We have what's called the vertical line test. And the vertical line test is just what I did here with this blue line. You put a vertical line because that's an x value. And if it intersects the graph in more than one spot, it's not a function. So the vertical line test says if any vertical line intersects the graph in more than one point, then what that means is that particular graph does not represent a function. So it will not represent a function. So what will happen is you guys will be given lots of graphs, and you have to eyeball, is there any spot where the graph intersects in more than one spot? And there's some tricky little pieces around this. We'll do a couple of examples for you to see that might be a little tricky. Let's look at an example to decide if something's a function. So for example, suppose I give you a graph of an equation with x and y, and the graph is a sideways parabola. And I know that this equation is x equals y squared. We'll talk about that later. You'll be plugging in x and y values. This is not a function. I actually have many, but here's one vertical line that intersects in more than one spot, so it's not a function. Now I'm going to do another graph that's going to be a little trickier, and you tell me if it's a function. When you come back, you'll see the graph right there. It's just going to appear magically. I've just put this picture of a function, and I've just introduced a notation. Y is some graph, some expression with x, and we call it f of x, function of x. So the big question in this one, is this a function? So tricky as this is not a function, and I'm going to abbreviate function FCM, because when x is 0, you have two different y values. So you could think of it as a horizontal line hitting it in two places. So that means two y values.